Hello dear students, and welcome back to a new lesson. Now in the previous lesson we finished uniform acceleration, which we had 4 equations for uniform acceleration, and we solved many problems for each one of them. In this section and in this lesson we'll be reaching falling objects and free fall. Now before I talk about falling objects and free fall, let me ask you a very simple question. If you have a paper in your hand, in your right hand, and in your left hand you have a stone, or be it any other object, a solid one, a rigid one, which one is going to fall faster? The rock or the paper? Of course, we know that the stone is going to land and hit the ground sooner than the rock. So the first object to hit the ground is the stone, the rock, okay? Now, the important part here is, what is the reason why the paper is floating in the air while the stone has hit the ground? What could be the reason? If you have not studied physics, you would say, because the stone has a greater mass. Well, that's not true. Why? Because if you fold the paper in your hand, okay, if you fold the paper, make it smaller, you would see that the stone and the paper fall almost exactly at the same time. So what did we change? Nothing. We just folded the paper, we just changed the size and the shape of the paper, and then you have what? We have a situation where both the paper and the rock or the stone fall at the same time. So what could be the reason? I'll ask you. Pause the video and think about it. The paper, when it's flat, when it's not folded, has a greater surface area, while the stone has less surface area. So paper, because it has a larger surface area, is going to be exposed to more air molecules. Okay, that is why air resistance comes in. Okay, that is where air resistance comes in, and it plays a huge role when it comes to falling objects. Okay, so it's not only the force of gravity which affects objects, it is also air resistance. Okay, the greater the area, the more it's going to be exposed to air molecules. Okay, that is why the stone fell sooner than the paper. Okay, now when we talk about falling objects in physics, almost in every case we forget about air resistance. Why? Because it makes calculations complicated. Okay, so we don't talk about air resistance. We have fallen objects. Fallen object is basically the motion of a body under the influence of gravity alone, with the absence of air resistance. There is a video, I recommend you watch it, and I'll try to put the video here, where you have a feather and a ball. In the first situation where you let them fall, you're going to see that the feather is floating in the air while the ball has already hit the ground. Okay. In the second situation, they are going to remove the air in the room. Okay, they create a vacuum chamber. If you remove the air from a room, it means that you have removed their resistance. Okay, so what is a resistance? It's basically the molecules of the air resisting the motion of an object. Okay, so when they remove the air, they're going to create a vacuum chamber. If they let the feather and the ball go, you're going to see that they're going to fall exactly at the same time. Now, what is the acceleration? It is an important question here. What is the acceleration of a falling object? The acceleration of a falling object, I'm sure you have heard about this, is 9.81 meter per second squared. What is the acceleration if I ask you, for example, I have this calculator and I have this pen in my hand. Okay? If I let these two objects go and they fall, which one has a greater acceleration? You tell me, which one? Both of them have the same acceleration. Careful. Acceleration does not change when it comes to falling objects. Basically, when we say acceleration, we mean gravity, gravitational acceleration, which is equal to 9.81. It's constant. It doesn't change. If an object is moving, if I'm sitting here right now, the influence of gravity, the impact of gravity on my body is equal to 9.81 meter per second squared. It doesn't change. Okay? Whether I go to the next room, or I stay here, or I move, or I am not moving. Okay? So acceleration does not change. Please keep this in your mind. Okay? Now we have a situation here where you let a ball, okay? You throw a ball in the air, okay? Now when you throw the ball in the air, slowly, okay, the velocity of the ball is going to decrease. Let's say it's like this until it reaches this point, okay? So look, you throw the ball in the air, it's going to slow down until it reaches here. You can try this at home if you have a ball. Then, when it reaches here, the velocity is going to be equal to 0. Now it's going to fall back, okay, and hit the ground. Let me draw this for you. So let's say we have a ball, and you throw this ball in the air. The velocity is going to what? The velocity is going to, or the object is going to slow down as it is rising, okay? When the object, let's say, is here, or is at the highest point, velocity is going to be equal to what? Velocity at the peak. If I ask you, for example, what is the velocity of the object at the highest point? It's going to be what? Velocity is going to be 0 meter per second. Careful. Okay? Then the object is going to what? The object is going to fall back. Okay? And hit the ground. Okay? Now, this is what happens when you throw a ball in the air. Okay? This image is what basically is just basically when you throw a ball in the air. Okay, now we have several questions, very easy questions, I'm sure you know them. When the ball reaches the highest point, what is the velocity? I just told you, when the object reaches the highest point, then velocity is going to be equal to 0. Okay? Please try this at home. Throw a ball in the air or any object. You'll see that at some point, at a very instant, okay, a small, what we call at an instant of time, the ball or the object is going to stop and be stationary, and then it's going to fall back. Okay? So at the highest point, or when the object reaches the highest point, the velocity is going to be 0. What happens to the velocity of an object thrown in the upward direction? Okay, so if you throw an object in the upward direction, the velocity is going to slow down, or the velocity is going to decrease until it reaches the highest point where velocity becomes 0. A very important question here, it says, what happens to the acceleration of an object? Nothing. It remains constant. 9.81 meter per second squared. Okay? It doesn't change. Whether the object is slowing down or it's speeding up, whether the object is stationary or it's moving, doesn't matter. 9.81 meter per second squared. Okay? بابا كرديش بيكتوز بوتان شرح كم بوانيك إنجليزيان باجني زور أو سيكشن باسي فولن أوبجيكتس دكا يعني وتناني كده كون أخواروا اشتك معناه بيدلن فري فول فري فول سيا أو هيك لكاتي شرح كرني برسيار دا يعني لكاتي كاتك لو تنانا دكولينوا كده جولين تنيا كار لسر يك هيز دكين كار لسر يك فورس دكين ككار دكاتا سر أو تنا بابلين أو قلم مان هي أما إيه ريزيستنس مان هي باشا فريكشن مان هي باشا أو لا دين باسي أو يناكين تنيا باسي جرافيتي دكين أو بيدلن فري فول باشا فولين أوبجكت أو هيك كتنيا لجير كاري جرافيتية جرافيتي جكسانة بتند 9.81 متر لەسەر چرکە دووجە باشە ئەو ئاگادار بە ئەو ئیگزامپڵە ئەو نمونەی کە لێرە هەیە دەڵێ چی دەڵێ what is the acceleration of an object when it is going up and when it is moving دەڵێ کاتێک کە تەنەک بەرز دەبیتەوە یعنیش نزم دەبیتەوە ئەکسلەرێشنی چەندە ناگۆڕێ ئاگادار بە لە هەموو حاڵەتێکدا ئەگەر تەنەکە بزوولێت ئەگەر تەنەکە نەزوولێت ئەگەر تەنەکە بەرز بیتەوە ئەگەر تەنەکە بێتە خوارێ 9.81 ئاگادار بە باشە لێرە نمونەکمان هەیە دەڵێ کاتێک کە تۆپەک ئەوای فرە دەدەیە با بڵێن هەوا سەرەتا خێراییەکەی کەم دەکا تاوەکو دەگاتە بەرزترین ئاست کاتێک کە دەگاتە بەرزترین ئاست ڤیلۆسیتی یەکسانە بە سفر جوان لەگەڵم بە تەماشاکە تۆپەکەی فرە دەدەی ئەلێرە با بڵێن ڤیلۆسیتێکی کەم دەکا هەتا دەگاتە ئێرە باشە لێرە ڤیلۆسیتێکی یەکسانە بە سفر دواتر دێتەوە خوارێ باشە ئەوە لێرە باسیەوە ئەکات ئەو پرسیارانەمان هەیە دەڵێ چی ڕوو دەدات یانیش کاتێککە تۆپەک دەگاتە بەرزترین خاڵ چی بەسەر ڤیلۆسیتەکەی دادێت ڤیلۆسیتەکەی دەبێتە سفر باشە ئەدی ئەگەر تۆپەک بەرەوها بەهاوێژی ئەویان چی بەسەر ڤیلۆسیتەکەی دادێت بەو شێوەیە دەڵێن when the ball با بە ئینگلیزیش فێر بیت دەڵێ when the ball is thrown in the air the velocity is going to slow down until it reaches the highest point where the velocity becomes zero باشا أوه acceleration is 9.81 meter per second squared okay it's constant and it doesn't change Pasha some important point here is that when we talk about gravitational acceleration we're going to say G is equal to negative 9.81 meter per second squared. Basha or negative here. What is this negative here? Does it mean that acceleration is decreasing? No. Agadarba. When an object falls, it's going toward the center of the earth or it's going downward. Remember, downward means what? Means negative. Okay? This negative only shows direction. Okay, it doesn't show or it doesn't tell us that the velocity or the acceleration is decreasing. No, it's only talking about or it only shows that the direction is toward or it's downward. Okay. أو ياسايا كبشتر بكارمان دهينا لuniform acceleration همان ياسايا تانية A acceleration is gonna be changed into G 9.81 delta x دبيتا delta y which is equal to y final minus y initial هماش معنى بو delta x was equal to x final minus x initial ليرة دبيتا y بوتي اواهي ليدي لبروي بيشتر we were talking about acceleration او acceleration كوبو horizontal بو يعني بون منا تنكان اواهي دزولان بزو جارين تنكان بوشوي دزولان vertically كواتا G بسمان vertical دلتا وايش بسمان vertical لبرو سمبولا كان دا غوردر ليرا او ياسانا بكاردهينين دوباره تمشايك V final is equal to V initial plus G delta T you see before it was A delta T again we have by the way we use this when delta x is not mentioned او بو بيشتربو بلام ليرا دلين delta y is not mentioned V final squared is equal to V initial squared plus 2G delta y. اگر باسی کات نکرابو او یاسای بکاردینین delta y is equal to V initial multiplied by delta t plus 1 over 2G delta t squared. ليرة تنيا سياسة من هي اگر اگر بي ياسايش كش معنى و پیشتر دمان قد delta x يكسانه با 1 over 2 V initial plus V final delta t. او ياساي بكارنينين بو لبروي نا دلتا واي تدايا سوري جي تدانية acceleration تدانية كاتو ياسايا استفادة نية بوما باشا دبروي gravity تدانية باشا acceleration تدانية كاتنيا وسياسانا بكاردينين ياساي تشكش لكول بوا باشا او برسيارة من هي دالي باوان hits a volleyball so that it moves with an initial velocity of 6 meter per second تمشايك V initial يكسانا با 6 meter per second Okay. If the volleyball starts from 2 meters above the floor, how long will it be in the air before it strikes the floor? Delta y is equal to negative 2 meter. باش بارك أود بو شرحكم باش بو negative 2 خدتني هذا 2 meters بأود بو let me draw this for you so you better understand this. تماشا هيك دلي سيسارته delay. The ball is 2 meters above the ground. Okay, so 2 meters above the ground. Okay, this is going to what? This is going to move into the air and then fall back. When it lands on the ground, delta y, okay, or y is equal to 0 meter. Okay, now you know delta y is equal to y final minus y initial. Okay, is this y final or y initial? It's the first one that is mentioned, so this is y initial and this is y final. Let's put this in the equation. Delta y is equal to 0 meter minus 2 meter. So delta y is equal to negative 2 meters. Okay, that's why we say it is negative 2. باشا أجا دربة لزوربي برسالة كان negative 2 بلا ما غير دنيا برسالة كان negative 2 نبو أو يبزانه باشا. Okay, now the question says delta t is equal to what? Okay, we know that gravity is equal to negative أقدر 9.81 meter per second squared. كم ياساي بكاردين بو دلتا تي أو ياساي بكارديني دلين v final is equal to v initial plus g delta t. Bash. Let's take a good look at the givens. We don't have v final. We should first find v final. We have v initial, we have gravity, we need to find delta t. Okay, let's first find v final. So what equation do we use to find v final? We have the other equation. V final squared is equal to v initial squared plus 2g delta y. Okay, so v final squared is equal to 6 squared plus 2 times negative 9.81 times negative 2. Okay, so v final squared is equal to what? Is equal to 75.24. So 75.24. Okay, now take the square root of this. Okay, 75.24. We have 8 points, so v final is equal to 8.67 meter per second. Well, I'm leading here. Okay, أود بالكاري خوندية كاتك when you take the square root of a number we're gonna say plus or minus. Okay, plus or minus. أو بولي ربيس مانا باش بالي ربودرون كما لبر when the ball is moving into the air, okay, v initial is equal to 6 meters. When it goes down, v final is negative. Okay, that's why we're going to take the negative one. Okay, so we're going to say v final is equal to negative 8.67 meter per second. Basha, يلا delta t بدوزينو. V final is equal to negative 8.67, which is equal to 6 plus negative 9.81 multiplied by delta t. And then move this 6 to the other side, it becomes negative 8.67 minus 6 which is equal to negative 9.81 multiplied by delta t. Divide this by negative 9.81. Divide the other side by negative 9.81. This one cancels. Delta t is equal to 1.5 seconds. Okay, that is sample problem 1F. Okay, let's solve practice 1F. It says a robot drops a camera off the rim of a 239-meter cliff. First of all, the camera is not moving. So V initial, let me use black. V initial is equal to 0 meter per second. Okay. What about delta y? Delta y is equal to negative 239 meter. Okay. Why negative? You know. Okay. I just showed you. With the free fall, acceleration is negative 3.7. Okay, it's not 9.81. It tells you that G, because we are on Mars, 3.7 meter per second squared. A, it says what? V final is equal to what? It says find the velocity with which the camera hits the ground. So V final is equal to what? So V final is equal to V final squared. Let me use this color. We're going to say V final squared is equal to V initial squared plus 2G delta Y. V final, let's take the square root directly, is equal to 0 squared plus 2 times negative 3.7 times negative 239. Okay, so 0, we don't have to even care about this. So 2 times negative 3.7 times 239. Negative 239. We have what? We have 42.05. So V final is equal to plus or minus, but we're going to take what? We're going to take the negative one. So negative 42.05 meter per second. Okay. Why did we take the negative one? Because V final is toward the ground. Okay, that's why the direction is going to be negative. Okay, let's find B. B, it says what? Find the required the time required for it to the ground. So delta t is equal to what? So we found V final, which is equal to 42.05 negative 42.05 meter per second. Then let's find delta t. So delta t is equal to what? Delta t is equal to V final minus V initial divided by G. Okay, please just learn how to rearrange the equation so you can save time. Okay, so V final is equal to a negative 42.05, okay, minus 0, which is V initial, divided by G, which is equal to negative 3.7. The two negatives cancel, so 42.05 divided by 3.7, we have 11.3, so 11.3 seconds. Okay. If you don't know where did I get this, guys, come on, it's just V final, which is equal to V initial plus G delta t. Just move this V initial here, divide this by G, and that's it. Okay, let's solve question 2. A flower pot, guldan, falls from a windowsill 25 meters above the sidewalk. So we know, let's write the givens. Delta y is equal to negative 25 meters. Okay, negative 25 meters. Okay, now it says what? It says how fast is the flower pot moving? Before that, before we reach that, we know that V initial is equal to 0 meter per second. Why? Because the flower pot is not moving, okay, in the first place. Then it falls. We know that gravity is equal to negative 9.81 meter per second squared. Okay? A, it says, how fast is the flower pot moving? Okay, so V final is equal to what? When it strikes the ground. So V final squared is equal to V initial squared plus 2g delta y. V final, take the square root, so V final is equal to 0 squared plus 2 times negative 9.81 and then times negative 25. Okay, 0 is not going to change anything, so square root of 2 times negative 9.81 times negative 25. So we have what? We have 20, so you know V final, because we took the square root, is going to be plus or minus 21.14, but I'm going to take the negative one because it's going down, so negative 22.1 meter per second. Okay, question B, it says, how much time does a passerby of height 1.8 meter on the sidewalk below have to move out before the flower pot hits the ground? Okay, now let me try you something before we solve question B. Okay, if this is the flower pot and in the first place it is moving and it's equal to 25 meter. What if somebody stands there? So let's say this is somebody and his height is equal to 1.8. So we're going to subtract that from the 25, so we get how much? Until this part hits his head. So it's going to be 25 minus 1.8, we have 23.2 meters. That is our next delta y. So delta y this time is equal to 23.2 meters. Okay? Okay, now let's find the time it needs to be. So, you know, we should first find V final. So V final squared is equal to V initial squared plus 2g delta y. V final is equal to square root of 0 squared plus 2 times negative 9.81 times negative 23.2. Okay, let's take the square root. So we have square root of 2 times negative 9.81 multiplied by negative 23.2. We have plus or minus 21.3, so plus or minus, but we're going to take the minus, so 21.33 meter per second. Okay, that is V final. Let's find time. So delta t is equal to what? It is equal to V final minus V initial divided by gravity. V final is equal to negative 21.33. V initial is equal to 0, so divide by negative 9.81. The two minuses cancel, so negative 9.81, so it's going to be 2.17 meter per second. Sorry, second, because it's time. Okay, 2.17 seconds. That is how you solve part B. Let's solve question 3, and question 4 is going to be for you. Okay, I have homework for you. Now, a tennis ball is thrown vertically upward with an initial velocity of 8 meter per second. So V initial is equal to 8 meter per second. What will be the ball's speed when it returns to starting point? Okay, let's say this is the ball. It is going with 8 meters per second, and then it hits the ground again. What's delta y? So the ball is hitting the ground, so delta y is equal to 0. So delta y is equal to 0 meter. And then we know gravity is equal to what? 9.81 meter per second squared. Okay, now what will be the ball's speed? So v final A is equal to what? So you know v final squared is equal to v initial squared plus 2g delta y. Okay, so v final is equal to v initial is equal to 8, so 8 squared plus 2 times 9.81 multiplied by 0. Okay, so all of this becomes 0 basically. So let's take the square root of 8 squared. We have what? We have 8. Okay, 8, but we're gonna say plus or minus. Okay, plus or minus, but we're gonna take minus, so negative 8 meter per second. 8 squared is basically 64, so we're gonna say, okay, solve question 4. We just have v final, which is equal to 1.1 meter per second. You have to find delta y. Okay, let's solve some questions in section review. You don't have to solve any of them. I'm just gonna solve the important ones. A coin is tossed vertically upward. What happens to its velocity while it's in the air? Look, it says a coin is tossed vertically upward. What happens to the velocity while it's in the air? So when you toss the coin in the air, its velocity is gonna decrease. When it reaches the highest point, it's gonna be 0. Okay, does its acceleration increase or decrease or remain constant while it's in the air? It doesn't change, it remains constant. It's equal to 9.81, careful. Okay, we have question 2. It says a pebble is dropped down a well and it hits the water 1.5 seconds later. So we know delta t is equal to what? It is equal to 1.5 seconds. V initial we know is equal to 0 meter per second. Well, because it was not moving and then it started to move. G is equal to negative 9.81 meter per second squared. It says, using the equation for motion with constant acceleration, determine the distance from the edge. So delta y is equal to what? Okay, so you know delta y is equal to v initial delta t plus 1 over 2 g delta t squared. Just plug in the values and that's it. Okay, a ball is thrown vertically upward. What are its velocity and acceleration when it reaches maximum altitude? What is acceleration just before it hits the ground? So I told you when it reaches the maximum point or the highest point or the peak, the velocity is going to be 0. What happens to the acceleration if or before it hits the ground? It doesn't change. It's still 9.81, even when it's in the air. Okay, careful. The other questions are for you. In the next video, we will be solving some of the questions in chapter review, and then we'll be moving on to chapter 2. So until then, have a good time and see you in the next video.